Hey there, I'm Brendan Burns, Corporate Vice President in Microsoft Azure, focused on cloud-native open source technologies, and also one of the co-founders of the Kubernetes open source project. And I'm really excited to be here today to talk to you about the container past, present, and future. I wanted to start with the past of containers because I think even almost a decade in, it feels like containers are new technology. They're the next way that you're going to be building your applications. But the honest truth is that this technology has been around for quite a long time. And I think it's useful to take a look back to see the various motivations that led to the development of what we call containers or cloud native today. It all starts back in the late 1970s when a utility called chroot was added to BSD Linux. Now, chroot basically allowed a process to change its perspective about what the file system looked like. And that's the very beginning, I think, of what it meant to be a container. This idea that you would have an operating system with multiple different processes, each with a slightly different perspective about what that operating system looked like. chroot obviously is very simple. It just changes the root file system. It doesn't do much of what we would think of as being modern containers. But if we fast forward to the late 1990s, when the internet was really becoming a broadly used thing, there was additional developments in the form of BSD jails. And here the idea was, you're starting to put internet servers out into this, open internet. Security was definitely a concern. Suddenly all these programs were being accessed by all kinds of different people. And so jails were introduced as a way to isolate the processes from one another in a security way, right? So in addition to isolating the file system, we're going to isolate processes from security. Now, the final piece of the puzzle was added with Solaris zones and Linux C groups in the 2000s. And this was really focused on resource sharing. So ensuring that a particular process couldn't use too much of the memory or too much of the CPU. Now, of course, none of this really was things that most people were thinking about. If you were developing programs in the 90s or developing programs in the 2000s, containers wasn't really a part of your lexicon. So what happened in the 2010s was Docker really kind of took a bunch of these technologies together, along with the idea of having an immutable container image, some of the ideas around immutable infrastructure that were circulating at the time, and they created a really great developer experience. They said, you know what, this actually encapsulates a solution to a lot of problems that developers were having, especially as they moved from, having a single server where they might log in and download a new application, run that application, moving to a more cloud native approach, an immutable infrastructure approach, where you're creating brand new VMs every single time you do a release. You're using CI/CD and automation. Sorry, I have a timer in there. And finally, the last piece that came together was Kubernetes. And so we're going to move forward to the origins of Kubernetes, really. And that was all about seeing this revolution in containers happening in the way that an application was packaged and developed, and recognizing that it's not just about packaging and developing your application, but it's actually about figuring out how do you describe that application to a system that can take a bunch of actions on your behalf to take your desired state of an application and make it the actual state of an application. Now, I think the best analogy, and one of the ones that I had in my head, was drawn from watching my children play around with these quadcopter drones when I was thinking about the development of Kubernetes. I think back to my own childhood where I had a remote control plane. I spent a ton of time building this remote control plane, and it flew for literally 15 seconds before it crashed into the earth and destroyed itself. Now, if you fast forward to 2010, 2012, when my children were starting to play around with this kind of stuff, they were using an iPad to drive around a quadcopter in my house. And obviously, it didn't crash into the ground. It didn't destroy itself. And the reason for that isn't because my children are somehow better at flying airplanes than I am. The reason for that was there's intelligence inside the drone and inside the program that is taking their desired state, hey, I want this thing to go up or I want it to go forward, and turning it into the various commands to the motors to actually make the drone move in the right way. Kubernetes was drawn from that same inspiration. Building and deploying applications, if you're doing all of the different steps yourself, is simply too hard to do at large scale and with the reliability expectations of modern applications. And so when we were thinking about Kubernetes, we were really thinking about it as an autopilot for your cloud systems, as the thing that will wake up in the middle of the night and restart an application if it's failing so that you can keep sleeping and that your pager never goes off. Or as the thing that knows how to safely deploy an application from version 1 to version 2 without taking any downtime and without you really having to think about anything other than, I want my application to be upgraded. So this is really the origin of Kubernetes, was that idea that even as ourselves operating software, we saw the pain and the toil that people were having. We saw the benefits of containers that Docker was bringing to the scene, and we saw people adopting containers. But we knew that there had to be an orchestrator to take over a lot of the application running itself, and also to scale your application out to multiple machines. Now I'm going to step from that history, and that was sort of a very quick, whirlwind history of containers and Kubernetes, into the future. And I'm going to spend the rest of the talk talking about, where I think that the future of containers and Kubernetes is going. I think it's the more interesting part. So if you were here for the history, feel free to come and ask me questions on Twitter, but the rest of the talk is really going to be focused on the future. And in this discussion, I should always say this is, my thoughts and my ideas, my observations about what's happening. It's not necessarily, there's no guarantees, I guess, and plenty of other things exciting are happening in this space as well. And I think the best illustration of the fact that there are no guarantees in my prognostications of the future is the very first trend that we're seeing, which is that there are just lots and lots and lots of clusters for any particular customer or for any particular company. Now, this is something that I would say, as we were thinking about Kubernetes and we were developing it back in the history, we did not think that this was going to happen, right? We came from a world of bare metal infrastructure, of large scale data centers with 10,000, 20,000 machines running in them. And we fully expected that people would build very large clusters, and a company might have 5, 6, 7 clusters within a company with tens of thousands of nodes in every single cluster. What we have seen over the last 10 years is the exact opposite of that. Rather than having, tens of clusters with thousands of nodes, we're seeing companies have thousands of clusters with tens of nodes. And I think there's a bunch of different reasons for this. Some of it is pure organizational politics and bureaucracy. Even something as simple as chargeback makes it easier for 2 different business units to have 2 different clusters instead of a single, company sharing all of the resources. But it's also the case that because Kubernetes was inherently a cloud-based thing and had a cloud-based API for creating clusters and scaling clusters, we enabled individual developers to do things that they would never be able to do with bare metal. When we're building physical data centers, you can't just have your developer come along and say, hey, I would like my own data center of 10 machines. It just doesn't work. But in the cloud, with a cloud-based Kubernetes solution, that's exactly what developers do. They can very easily come along and say, hey, I'd like a 20-node cluster. And it instantly appears in Azure. In a handful of minutes, that cluster is available to you. And similarly in other, sort of the real world aspects of companies, as well as the ease with which clusters could be created and scaled within cloud-based infrastructure, has led to this significant disjunction and difference between the world of physical infrastructure, where there's very large clusters, and the world of cloud infrastructure, where there's lots of clusters and they're all very small. This in turn has caused a lot of problems for end users that we haven't anticipated. And so what we're thinking about as we move forward into this future within the way that we manage Kubernetes in Azure is thinking about how can we build capabilities to enable people to both manage lots of different clusters and also deploy their applications across these clusters. And I want to take a look at what a few of those are. The first is this idea of workload federation. When you have lots and lots of clusters, it becomes very hard to reason about, where specific applications should run. And sometimes it's even about reliability or efficiency of those applications. If you have to think about careful placement of each workload onto each of these small clusters, it can become very painful. And so what we're working on in workload federation is this idea of propagating workloads from a central hub cluster out to multiple member clusters, so that individual application teams can focus on just deploying their application, while the workload federation infrastructure thinks about placement policies and where to put resources that should be propagated out to a variety of different clusters. In this way, you could be thinking about saying, hey, you know what, I want to deploy my application. And the workload federation will think about things like, well, I need to deploy a part of it to this cluster and a part of it to that cluster in order to achieve the reliability that my policy dictates that I need to have. But it's not just about deploying your workload. We're also doing a bunch of work on east-west networking. This is an area that I would say has been underappreciated and under-addressed throughout the history of Kubernetes. There's been a lot of focus on how you do service-to-service networking within a cluster, but a lot less focus on how you do service-to-service networking between clusters. And in particular, while there have been various tools for exporting and importing services, it's only relatively recently that we've seen the Kubernetes community coming up to develop things like the multi-cluster service APIs. And we're doing our part within Azure to implement these multi-cluster service APIs to enable easy east-west networking between multiple clusters running in the Azure Kubernetes service. If you're interested in learning more about this multi-cluster service API, you can see the URL here for the development of the API that's happening out in the Kubernetes community and that we're participating in the development of. So we're really excited to see not just the fact that there are community APIs being developed to enable east-west networking between clusters, but also to see our Azure team stepping up and implementing those so that customers of Kubernetes on Azure can have easy access to the innovation that's happening out there in the community. Of course, east-west networking is great for building your application, but you also need to be doing north-south networking. And north-south networking is something that has been present in Kubernetes since the beginning. You know, the fundamental objects that we created in Kubernetes were, deployments, services, and pods. But it's been an area where I think that we've learned a lot over the last 10 years. And there's been more recent development on newer APIs. So the Gateway API, which used to be known as Ingress v2, is starting to coalesce around how we can think about building an HTTP API that is influenced by how people have been developing applications in Kubernetes over the last 10 years. And also what we've seen is that actually while service mesh and north-south gateway might feel like a different thing, there's actually a ton of commonality. And so as service mesh becomes more and more of a commonly held thing, we're seeing the move towards integrating gateway APIs with the service mesh interface to kind of present a more unified abstract interface for how you do application networking within Kubernetes. And of course, there'll be implementations of those APIs developed for Azure and developed for the open source solutions like the Open Service Mesh. And it's been great to actually see this sort of standardization and coalescing happen in the community over the last year so that, really at the end of the day, if you're a customer or you're a user of Kubernetes and, all you want to do really is get your application out to your users and your customers in an easy way, the kind of confusion that was in this space is settling down and really starting to develop some great solutions that I think will be a benefit of Kubernetes users everywhere. So I think all of those things are examples of ways in which we're addressing that trend of having lots and lots of clusters. There's still much more work to do, and we really do see it as an area that we need to focus both within our own Azure Kubernetes service, but also broadly within the Kubernetes ecosystem. Now, I want to branch from lots of clusters to another trend that has been sort of really present in the Kubernetes ecosystem over the last couple of years. And it's actually, I think, related to this idea of there being lots of clusters. And that's the idea of GitOps. Now, I think people have been sort of familiar with the idea of push to deploy, pioneered by PaaS providers like Heroku and others, this notion that when I push code into my application, it automatically gets deployed out into the cloud or into the application hosting platform. And what we're doing with GitOps is we're actually saying we're going to take that exact same pattern and that exact same paradigm, and we are going to apply it to managing your infrastructure. And so whenever you push a change out to a Git repository, that those changes to the infrastructure will be reflected back to the Kubernetes cluster that you're running. Maybe it's to upgrade a version of monitoring that you're running, or maybe it's to upgrade, an intrusion detection daemon set that you have in the cluster. There's a variety of different ways that GitOps can be used to really easily manage your infrastructure as code. But the most important part of it, I think, is this idea that it's scaling your DevOps, right? So if all you had was a single cluster, using automation and doing GitOps might not seem like that much of a win. But the truth is that as people have created more and more clusters, what we've seen is that there are things like policy files or Helm charts for standard utilities that get duplicated across these different clusters. In the worst possible scenario, somebody ran kube control apply with a local file into each of these clusters, and then that file is only sitting somewhere on their hard drive. Now, most people understand that's probably problematic, and they've at least created multiple directories, one for each cluster, with all of the different files that they've used to describe the contents of their cluster. But even that is pretty problematic, because when you iterate forward and you make changes, let's say you see a CVE and you need to rev the version of an image to address a security vulnerability, or there's a bug and you need to scale up a particular microservice in order to respond to a bug, those changes sometimes don't get propagated everywhere. If you make the change in one cluster, it may or may not get copied into the files for the other clusters. And over time, you see skew and drift between the configurations to the point where, if the original goal of Kubernetes was to get rid of Snowflake VMs, we've now created a whole bunch of Snowflake clusters. And it really becomes hard to scale your DevOps motion if you're maintaining all of these individual copies. And what GitOps does instead is it actually says, hey, you know what? We can combine a single Git repository, a single location in GitHub, with Azure GitOps and with open source technology like Flux, and you can have a single configuration file that is replicated out automatically to all of those different clusters. Now, the value here is that instead of having to cut and paste and remember to make sure that you keep all of your clusters in sync, and for you to have to push the configuration out into those production clusters, with GitOps, the clusters themselves are paying attention to the Git repository. They're watching the Git repository for any changes, and they're automatically applying the changes as they appear. This dramatically simplifies the operations of the developer operations or DevOps of scaling your cluster, of configuring your clusters, because your developer just has to send a PR to a Git repository, get the PR reviewed, see that the PR is merged, and Flux takes care of pushing it out to all of the different clusters that you're managing. And when we talk about Flux, it's really important to note this is a project that has been out in the Cloud Native Compute Foundation for a long time. And in fact, it's a project that started by a company called Weaveworks that is not a part of Microsoft. And I think it's just such a great illustration of how we can benefit from and participate in open source innovation by not reinventing the wheel, by not going and doing it our own way or integrating it tightly with anything that we control, but actually going out there, finding a great open source solution that's been donated to the CNCF, and then starting to contribute both to Flux and the Flux community, but also obviously with our participation in GitOps, with workflows and other kinds of ways of integrating GitHub as the hosting solution with Flux as the GitOps solution. And so these pieces really come together, and I think are a great illustration of how, within Microsoft and within Azure, we can provide a complete end-to-end experience that's truly unique in the industry. But of course, if you prefer to use your own Git servers or Git servers hosted by anyone else, that works as well. We really view these as modules, and we even see people rolling their own solutions for GitOps rather than using the version that's integrated with the Azure Kubernetes service. All of those things are possible. Of course, if you just want to sort of get on with your day and focus on the management of your clusters, we can provide really great supported and automated solutions that work for you at scale. So moving from GitOps onto the next trend, I mentioned it briefly when I was talking about some of the things that you might want to use GitOps to push out. But one of the things that we've really started seeing over the last couple of years is a focus on policy and governance. Part of this is because the applications that are being deployed into Kubernetes are maturing and becoming more and more mission critical. And the kinds of companies that are using Kubernetes are using it for regulated activities like financial services, healthcare, and many, many others. And because of that, there's just a really strong need to have the right kind of policy and the right kind of governance in place to ensure things like data privacy, security, and even at times reliability. And I think one of the things we really try and think about when we think about policy and governance is how do we balance the business needs and or the regulatory needs with the agility that developers need. Because at the end of the day, Kubernetes was all about empowering developers to manage their own infrastructure. And if someone has to file a ticket to create a new pod in a Kubernetes cluster, that's not really a cloud native way of doing applications. And yet policy and governance are actually critical to ensuring that developers build secure and reliable applications. And so we've really focused on OPA, the Open Policy Agent, the language Rego, which is within that Open Policy Agent framework, and then Kubernetes policy itself with a project called Gatekeeper. When we started seeing the needs for policy come in from our customers, we actually sat down and wrote the first version of the Gatekeeper project, donated it to the CNCF, got involved with the Open Policy Agent project, and have seen it really become the way of doing policy within Kubernetes going forward, which is truly fantastic. I think it's a great example of how we can both do innovation and address customer need at the exact same time. Of course, one of the challenges that we run into with Kubernetes is actually trying to describe to people, well, why is policy a key part of securing Kubernetes? And I think this gives you a great example. Hopefully, you're already using RBAC or role-based access control for securing your cluster. That's great at keeping out the bad actors and letting the good people in. But the trouble is that when you let those good people in, they can still make mistakes. And within each resource that they create, they could make the wrong decisions. For example, someone creating a deployment of an application could specify an image that is coming off an insecure registry or coming off a third-party registry where you don't have a secure software supply chain. You want someone to ask, where is that image from? Or another question might be, you're putting something on the public internet. Did you get a security review for that? Or even something as simple as, who's running this service? Because we can build great automation around the Kubernetes APIs, but we can't build great automation if we don't know who to contact when we detect a container that's insecure. So a key part of policy is not just securing the container, it's actually ensuring that the metadata that's attached to a particular container contains sufficient data and accurate data so that when a security issue happens, it becomes an actionable security issue instead of a problem that you don't know how to solve. Now, in addition to all those questions that I just laid out, we're also focusing on developing guardrails. Guardrails are a little bit more developer and a little bit more reliability oriented. They're based on things that we've seen our customers run into problems with in the past, and taking some of those things and encoding them into policies that you can install onto your cluster so that you don't have to become an expert in the policy language. You don't have to necessarily become an expert in how to manage Kubernetes correctly. You can take advantage effectively of all of the learning that we've done over the last years. Some examples of some of the guardrails that we have in development are things like requiring liveness or readiness probes, ensuring that CPU and memory limits are set, or even requiring unique service names, because if you don't have unique service names, you can run into conflicts and problems. And this is an area where we, again, expect to continue to work with the community as we develop these guardrails to identify other patterns that they're seeing that they would like to see addressed. And of course, over time, as people become more sophisticated, they can also add in their own by authoring them in the policy language for Kubernetes. I think the next trend that I want to talk about is specifically about the developers and is related to that idea of making it easier for developers to do the right thing. So over the past, number of years, there's always been an idea of PaaS, or platform as a service. And I think what has happened as Kubernetes and containers took over a lot of the problems that PaaS was trying to solve in terms of application packaging and deployment, the value proposition of PaaS has sort of declined a little bit, to the point where I think most new development applications that are happening in Kubernetes and in containers. And so PaaS has sort of, entered a moment where modularity becomes more important than the ease of packaging that it provides. But at the same time, those developer ideas of a function-driven programming environment, or a really simple way to just run a snippet of code somewhere in response to a particular event, those are really, really powerful ideas that make it easier for developers to build and deploy applications. And so what we're seeing in the development of PaaS is not that PaaS is dead, but that in fact PaaS is restructuring itself. And so that the modern platforms that are being built are platforms that are being built on top of Kubernetes, and are platforms that are aware that they are running on Kubernetes. So it's not just like we're going to build Azure Functions on top of Kubernetes and hide that fact from the user. It's saying, actually, we're going to build a functions as a service interface on top of Kubernetes and ensure that it can run next to an operator that's deployed from a Helm chart, or next to a pure YAML application that is using all of the Kubernetes primitives. And I think this is the key part, that we have to be building in modular terms and in ways where all of the applications, no matter how they're deployed, share the same substrate. Now, in order to do that, we've been developing a bunch of core building blocks, the sort of shared libraries of Kubernetes, if you will. Tools like Kata or Dapper that multiple different programs in different environments can take advantage of, and toolkits that people can use regardless of how they're choosing to deploy their applications. So if we look at something like Kata, or the Kubernetes Event-Driven Autoscaler, which is a CNCF project in incubation headed towards graduation, it's really all about autoscaling made simple so that you can have your workload, any kind of workload that's based on events running in a Kubernetes cluster. So historically, autoscaling has been based on maybe CPU metrics or memory metrics, but for many workloads, it's actually all about files in a bucket, or messages on a Kafka queue. Kata makes it possible for a Kubernetes application to scale in response to those kinds of events. And more importantly, it's actually also got a ton of built-ins that it can watch for you. So it's not just sort of a generic infrastructure. It's something that you can use today with the existing stuff that you would expect to generate the events in your system. It also supports scale to zero, which is a huge value proposition for people who want to be truly idle if there's no workload. So you can easily imagine applications where there's a daylight cycle and a nighttime cycle, and at night there is no work to be processed. If you can scale back to zero, you can reduce your CPU consumption to absolutely nothing. It's good for the costs, and it's also good for environmental sustainability, because you won't be consuming any resources when there's no work to be done. In addition to Kata, we've also been focused on Dapper. Dapper is the distributed systems application programming runtime. It's really, the idea behind it is developing a central shared library for systems that are being built in any programming language, and being able to enable them over simple HTTP or gRPC APIs to a sidecar, enable them to access a whole bunch of shared implementations of the core building blocks of distributed systems. So for example, service-to-service invocation, or publish and subscribe resource bindings, or actor models are available to people no matter what code they write, no matter what language they write in, by talking to this Dapper sidecar. And Dapper provides, I think, a unified programming model, something that you might otherwise have only seen in event-driven programming languages, or in functions as a service, is now available to you when you are in a bare container, when you're in a programming environment, or anywhere in between within that Kubernetes infrastructure. It's also built as an open source project and available on any cloud or edge infrastructure. You can even run it in traditional virtual machines without any containers anywhere around, if that's what your need is. The final trend that I wanted to talk about is this idea of a better service mesh. And I think that when we think about service mesh, it's been an area that a lot of people have been exploring for a while, but has been something that has been maybe a little bit confusing to people, or has been something that people have been wondering whether they should dip their toes into. I think one of the really great things that we've been seeing recently has been a consolidation in the service mesh space. And in particular, a trend towards things like eBPF. So over time, service mesh started in sidecars, and they're moving towards eBPF. I think when we think about a better service mesh, what we're actually thinking about is how do we take eBPF even further? How do we take the ability to introspect within the kernel, and really provide not just meshing capabilities, but true insight into your running application. A project that we're working on that I'd love to highlight there is this project called Inspector Gadget. eBPF and service mesh can be really complicated for people. Inspector Gadget brings a ton of the power of eBPF to people super easily. And in fact, it's integrated with kube control if you use the gadget tool, and you can deploy these eBPF-based gadgets into your cluster to get advice about how your application is deployed, audit information, tracing top CPU usage, top network usage, profiles, and many, many more. So if you have been sort of hesitant to dive into the world of eBPF, or you're not exactly sure the benefits that it could bring for you, definitely check out this project. It makes it super easy for a variety of people to get started. I wanted to also talk with something that I think is really kind of into the future. This is everything that we've talked about so far, I think, are things that you would take advantage of today. I think the final piece of flexible compute is really talking about where I think we are headed. And the idea behind flexible compute is this notion that, while containers and cloud native applications have revolutionized the way we build distributed systems, the truth is that our distributed systems are no longer just things that run in the data center. They're applications that span from a data center, but all the way down to a mobile device or a small embedded chip running on a factory line. And so we're going to need to be thinking about flexible compute that can move from the cloud to factory environments where the devices need to be very, very small and cheap, or even to shipboard environments where the network connectivity is very, very poor. Right. And we don't want, when we think about things like machine learning, I don't want to have a separate team developing machine learning models in the cloud, on the factory floor, or to run on a ship. We need a piece of code and a machine learning model that can move through all of those different environments. Obviously, maybe it's not going to be as powerful on an embedded device as it could be in the cloud. And obviously, maybe it needs to run on your own hardware when it's running in the ship, and it needs to use models that are stored locally instead of constantly updated cloud-based models. But all of those things are dimensions of the compute. They don't change the code itself. And so when we think about flexible compute, what we're really thinking about is how can a single team write code that moves between all of these different environments. And I think that it may be the case that we are headed towards a new container environment. So previously, when we thought about containers, they were encapsulations of things that are in the operating system already. When we look at WebAssembly and the WebAssembly Systems Interface, or WASI, I think we have the opportunity to define a new kind of container. We're no longer bound to the primitives that are in the operating system. We can actually imagine whatever kind of capabilities, or alternatively limit capabilities for security and reliability purposes. So the great thing about the WebAssembly sandbox is that it's targetable from any language, it's a runtime, and it's an opt-in runtime, meaning it starts with effectively no capabilities, and the capabilities that we add are only the capabilities that we want to add. Because the truth is that when we think about our containers infrastructure, the cloud native APIs in Kubernetes that we're using to describe our application, they're modern APIs developed within the last 10 years and really focused on the needs of the modern ecosystem. But when we look at what's under the hood, when that container starts running on a Linux operating system, that container is connected to machine level and operating system level APIs that are really been pretty static since the 1970s. And so I think the value when we think about flexible compute and we think about how we build truly portable interfaces is in rethinking what it means to be a container. We've developed cloud native APIs and modern technologies for deploying and describing our applications. I think the most exciting thing that we can be thinking about in the future is figuring out the modern cloud native APIs for how those containers run once they get to the compute execution environment. So that's it. Thank you so much. If you're interested in learning more, please check out this URL, or you can get at it really quickly with the QR code. Thank you again for taking the time to be with me today. I apologize that I can't be there in person. I've really enjoyed putting this talk together, and I look forward to talking to you more about it on Twitter or in person if our paths happen to cross. Thank you so much.
Estamos aquí luego de la charla de Brendan Burns y estamos con Brendan Burns aquí presente. Nos va a estar, ahí está mandando un saludo para todos ustedes. Muchas gracias por estar y seguirnos hasta aquí, al final de la última charla del día. Por supuesto, el plato fuerte. Y la verdad, bueno, es un honor estar para nosotros con Brendan aquí. Así que acuérdense que ahí en Swapcard, métanse en la sección del chat, en la parte de preguntas, dejen sus preguntas que las vamos a estar leyendo en vivo para Brendan y las va a contestar él. Y tenemos un rato, así que hagan todas las preguntas que quieran, vamos a tener tiempo esta vez. Muchas gracias, voy a empezar y voy a pasar en inglés. So, Brendan, thank you for being here. Thank you for your amazing talk and taking the time to share with the Latin American dev community. We are big fans. We all use this piece of software you kickstarted a few years ago. So thank you so much for doing so. I know, sometimes it's a love-hate relationship with Kubernetes, but we all love it. Yeah, we all use it, and we are thankful for that. So thank you so much, and we are honored to have you here. So,
absolutely.
If you think it's okay, let's start with the questions.
For sure, let's do it.
All right.
Thanks.
So, the first one is if there's going to be any kind of migration tools that Azure offers to migrate service mesh like ECO or Linkerd to eBPF in a context that you were talking about.
Yeah. Well, I mean, I think that the work for eBPF for service mesh is still pretty new, right? So I think it's a little bit more in the early adopter phase rather than the migration phase. But I think one of the things we're always committed to with everything that we do in Azure is that people can upgrade from the things that they're currently using on Azure to anything new that we build. That's actually a lesson we learned really early on, the hard way, I guess. We'd come out with some new features and we'd say, hey, you know what, you can do it, you just have to create a whole new cluster. And clearly, that didn't make people happy. And so now we really do focus on that migration path for everything that we build. Although eBPF, as I said right now, I think that's something that we're starting to integrate. into things like our CNI, and eventually we'll get to things like our service mesh. So it's definitely early days for eBPF specifically.
Okay, that's great. So another question is, one thing that happens a lot, like even if Kubernetes has become in a way the Linux of the cloud, like the OS of the cloud, there's still like a lot of folks getting started to it. And personally, I've been working with Kubernetes for like 3 years now or more, and I still feel like a newbie. It's like I'm getting started every day with it. So, what's your advice for someone that's getting started with it, like to kind of figuring out a healthy path, down the rabbit hole, because it becomes a rabbit hole pretty fast. So, what's your advice for someone that, they know infra, they know maybe the cloud, but they're like getting into the manifests and the, the extensions and the charts, and so how should a newcomer take it?
Yeah, I think there's maybe 3 things I would say. Yeah. One is there's some really great tools out there, whether it's a bunch of the work that we did in VS Code to add Kubernetes extension support to VS Code, where you can get a tooltip if you're sitting in the YAML file and you're like, what is this field again? You can hover over it. You'll get a little tooltip that describes what it is. Help you learn kube control, because I think people hit kube control -help and it's pretty big, and so we've done a little bit more integration. So if you want to get a terminal into a pod, you can right-click on the pod and just select terminal or select port forwarding. So I think that's one thing. And other people have built good, some good tooling too. There's a project called Headlamp that is done by a company called Kinvolk that's out on GitHub. Headlamp allows you to build a web UX if you want to build sort of a web dashboard for end users. So I think that, like, figuring out what the good tooling is. I think also embracing this idea that it's going to be a gradual learning process, and that it's going to be kind of an on-demand learning process. So, like, I think we see some people and they're like, no, I must understand every single icon in the CNCF ecosystem before I can start, right? Yeah. And you're like, there's like 600 icons there, you're not going to get there. So, I think focusing instead on what do I need to know to get my application up and running, and not, oh, somebody said I needed a service mesh and I needed this and I needed that, and those things can come, right? A lot of the stuff can be incrementally added. So I think that also helps keep the complexity under control. And then I think the last thing is, I think most people are probably aware, but there's a pretty great Kubernetes community, whether it's in local meetups or in the Slack channel or places like Stack Overflow or everywhere else. There's just a lot of people who are really happy to help you. And so figuring out how do you connect with those people, either in person locally at meetups or remotely via Slack. That's another great resource. And obviously the Slack is great because it's got categories. You want to learn more about Azure and Kubernetes? Well, there's a Azure and Kubernetes category. You can dive down in, and my team members and other people are there. So really, it helps you figure out who you want to connect with.
Oh, that's amazing. Thanks. Really useful. So, going a little bit more into kind of like day-to-day, CD work around Kubernetes. There's some folks that approach this as, I have this pipeline that maybe connects via kubectl to my cluster, perform some changes, or install some chart or whatever. And there's this trend around the different approach, which is the cluster being aware of the outside, the GitOps approach. So what's your take on GitOps applied to not just maybe Kubernetes itself, but like infrastructure, like Crossplane? So I don't know.
Yeah. Well, I would say, declarative infrastructure is a really good idea no matter what, right? So, I think doing something in a text file as opposed to running kube control on your command line, always a good idea, right? And having those files in a Git repository on GitHub, also a really good idea, because you can do code review, you can do pre-validation and all that sort of stuff. And so I think those are uniformly good ideas. And then I think the question people come down to is like, is it a push model or a pull model? And I think, you're probably always going to use a combination of the two. Because the push model gives you control of exactly what happens when, right? And that, whereas the pull model, it effectively, each cluster decides to upgrade whenever the cluster decides to upgrade. And so I think that, when you're thinking about a safe rollout across multiple regions, you probably don't want to change the application configuration in multiple regions at the same time, right? Because if you have a bug or you have a problem and you blast it out everywhere, suddenly like your entire site might go down. Whereas, I think applying a config to a particular cluster, yeah, you might want to do that all at once and trust that the Kubernetes deployment is going to, do health checking and do the slow rollout for you. And so I think we actually see people combining the two, maybe, and having a more pipeline-based deployment for, say, going to a canary and then going to region 1 and then going to region 2 and, maybe waiting some time, looking at monitoring, looking at other telemetry, maybe even having a human say, yeah, it's ready to go to the next stage. But then using something like GitOps to actually roll the configuration out to a specific cluster, because it's easier and in many cases sort of cleaner and more efficient to let the cluster upgrade itself in that local cluster domain. And you can go down a little bit and say, maybe I'll do it app by app and I'll have a pipeline that rolls out each application, but GitOps actually to update the deployment or to update the config map. And I don't think I'd really make a judgment one way or the other. I think you can go all the way and say, hey, do pipeline the whole way. I would be a little bit hesitant to do GitOps for everything and not have a little bit of a pipeline there to orchestrate the sort of a worldwide rollout. That's sort of my feelings about the balance of the two. I think they're both, really it's about how you combine the two together to achieve sort of stability for your application.
Sure. Perfect. So staged and declarative, reactive, based on the context, which always, rules, right? The context.
Yeah. Well, and I think in general, I would say most people don't want to do a rollout to multiple regions at the same time.
Yeah.
Right. That's usually dangerous.
Yeah, especially because different regions are like literally never at the same time, right? It's like 3 a.m. here is like 4 p.m. there. So yeah.
Yeah.
So a question from Nadir: what is the long-term future or vision for Kubernetes relating to managing, big loads of data or streaming data?
I think Kubernetes is great for a lot of those workloads. In fact, some of our largest clusters are people doing big data processing. And whether it's machine learning, I think all of the sort of modern machine learning frameworks for inference and for training are being run on Kubernetes. So I think it's a great pair for that. And for streaming as well, we just had some press around the fact that the NBA, the National Basketball Association in the United States, just launched their whole streaming platform on top of Microsoft Azure and actually on top of the Azure Kubernetes service. And so, if there's any basketball fans out there, if you're watching the NBA on the mobile app, you're using Kubernetes behind the scenes for streaming.
Yeah,
so it's pretty cool.
The NBA is pretty big here, especially after Manu Ginobili. He's a logo. Yeah, but we follow the NBA, so yeah, that's great to know. And do you foresee any major kind of changes in AKS and the offering, because it's like this managed Kubernetes cluster. I mean, I guess in a way during your talk you mentioned like it's good for applications to be aware, or sometimes it's good for applications to be aware that they're running in Kubernetes. Yeah. But sometimes you don't want that, which is what we could call the edge, right? But it's a trade-off, of course. But do you see any kind of like bold move from Azure for edge computing or hybrid edge? I don't know how it works. I imagine it's somehow, but I would love to hear your thoughts on it.
Yeah, I think there's a couple different interesting things. I mean, one is we're seeing a lot of traction for the sort of a factory level Kubernetes cluster, whether it's through Azure Stack HCI or our IoT products. We're seeing people who, obviously we're not going to roll Kubernetes out to a temperature sensor, right?
Yeah,
It doesn't make
course.
sense.
Though somebody probably did already, right?
No, somebody probably did. It's probably, it's like, yeah. But at this point, we're seeing a lot of people who need to do local data analytics or local machine learning before they, take the signals and push them up. And they want, they want a small scale cluster for that. Maybe it's a 3-node cluster or a 5-node cluster. But they also want to be able to manage that, right? If you have 10 different retail locations or factories or oil rigs or ships or whatever it is, like you don't want to have to go to each one in order to manage that cluster. And so, that little cluster is connected up to Azure Arc, which is our integration into, the big Azure public cloud. And so you can actually use the exact same GitOps to deploy to your edge environment and to deploy to your public cloud environment. And you can use the same policy configurations and a lot of the same tooling to work in both environments. And we really see that resonating with a lot of people, because I think, especially as people are starting to look at the macroeconomic climate, they don't want to have 2 different dev teams, right? They don't want to have an edge dev team and a cloud dev team. They need the same set of skills to work in both environments. So that's, I think, a lot of what we're doing. There's also a pretty cool open source project that we're working on called AKRI, A-K-R-I, that sort of focuses on IoT and blending IoT in with custom resource definitions, and how can you think about maybe not putting Kubernetes on the temperature sensor, but maybe representing the temperature sensor in the Kubernetes API.
Nice. Right. Thanks. On a different aspect of Kubernetes, we got a question about why or how was the decision made, or maybe it was just like whatever and we did it, right? But why, the strict choice for etcd for storage?
Well, it's actually not that strict.
Okay.
It's just nobody's ever bothered to implement anything else.
All right.
So like if you actually go into the source code, we actually put an abstraction, like we put an interface around all the etcd code.
Yeah.
And actually the things you have to implement in order to implement storage for Kubernetes are not that complicated. It's basically just like get and put with some optimistic locking, optimistic concurrency.
Yeah.
Right. And the ability to watch. And actually, so I've known some people who just as a like hack project pointed it at other backend stores, but nobody's ever productionized it or really done much with it. And so, I mean, I guess from that you can conclude that like etcd is good enough, or people don't really care.
Like most of us.
Yeah, like I think most people, like, I mean, it's as long as it does its job. I mean, I think it has been interesting in the sense that I know the etcd. The etcd community has kind of struggled at times.
Yeah.
Because, not that many people are wanting to come contribute either, right? And so I think we've had times actually where, that project has actually gotten kind of unhealthy, and we've had to say, wait a minute, like this thing is at the core of what we do. Like we're going to have to invest some stuff there in order to make sure it stays healthy, because like people want to contribute to the Kubernetes project, and we need to make sure that they understand that if they contribute to etcd, they are contributing to the Kubernetes project.
That's interesting. Thanks. Another question we have is, so that the really infrequent or infrequent thing you do in Kubernetes is like bootstrapping a cluster, right? It's like once you get it working, it kind of like works, and upgrading is easier than like bootstrapping from zero. But I was wondering if you can give any or talk to the fact of sometimes it becomes a bit complex to bringing up or to bootstrapping a cluster, for production use. Of course, there's quirks for every company and context, but there's these other projects like I don't know RKE or Rancher or K3S, COPS, whatever. What are your thoughts on that in terms of like or do you know if there are any plans to making it simpler or more like streamlined, or just good enough?
Yeah, I mean, I think a lot of energy went into like Cube ADM, and because early on it was even worse, right? And so a
Yes,
lot of
yes.
energy went into Cube ADM for managing clusters, and then that kind of evolved into the cluster API effort. And so cluster API, I think, is sort of the modern, somewhat platform agnostic way to create and administer clusters. It's still not fully sort of platform agnostic. We have a cluster API provider for Azure, and there's one for VMware and other clouds. And, they try and share some logic as much as they can, but they also have some very provider specific logic. I think the truth is that, for most people, they're going to be consuming this from a provider, right? Whether it's any of the distributions you're talking about or a cloud provider. And so, like, the pressure gradient to do something really, really turnkey there is maybe less than it would otherwise be, because for a lot of people, it's just, hey, I go to the web UX for my cloud provider and I press a couple buttons, or I run a command line script or a command line tool, and the cluster pops into existence. And I think suits most people. And so I think it's a little bit more hobbyist to do the bare metal stuff yourself, and that's probably just going to be the state of the art, just given where we're at.
Yeah. Yeah, makes sense. We have a question about if it's there. Let me see if I get this question correctly. But if there's any kind of like prototype or work being done on WASM, or a way, an API like Kubernetes today for WASM or something like that.
So interestingly, I'll take it and maybe I'll interpret, and hopefully I'll do the right to justify that question. What I think we've been looking at, so there's a couple different things. There's a tool that we've built called the Krustlet, 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 that is actually capable of running WebAssembly as effectively as pods.
Nice.
Which is kind of cool. It was a little bit of a proof of concept, but it's out there on GitHub and you can play around with it. And then more recently, we've been looking at seeing, if there's the ability to create a container D backend that uses WebAssembly instead of talking to, Docker and, the namespaces and the Linux primitives that Docker traditionally talks to, right? And that's definitely very proof of concept as well. But I think it's an interesting idea, because if you could do that, then you could sort of swap in WebAssembly at a level that Kubernetes doesn't even really know about.
Yeah.
Right. Kubernetes just sees, hey, I've got this image to run, and when it hits container D says, oh, it's a WebAssembly image. I'll run it in a WebAssembly runtime instead of in a Linux namespace runtime. Yeah. And that's pretty cool. I mean, it's very, very early days, I think, but it's been fun to sort of see that evolve. And actually, there's going to be a couple of WebAssembly talks. I was just talking to some folks. There's going to be some WebAssembly talks in the lead up to KubeCon next week that look pretty interesting as well. So I definitely think over the next year and a half, you're going to see more happening in that space.
That's great. Thanks. And so the next question, there's a trend I see happening in several development teams, which is, you're working on this, application, lots of microservices, different databases, some of them lightweight, some of them not, and you have your working development environment with running with Docker, Compose, or whatever, and it becomes really stressful for the machine. You can have 32 gigabytes of RAM and whatever, but you're running an M1 whatever, and it's like the architecture just performance-wise. So there's this talk about like how could we effectively have some hybrid development environments where I run locally what I'm coding, and anything else it's running on some Kubernetes cluster, and there's some tunneling. But you look at the things out there, and they're like very quirky, kind of messy. I don't know if you've had experience with these kind of situations, and what would be your recommended approach, and if you've actually found like a sweet spot where like this works.
Yeah, I mean, I actually think I have found a sweet spot here, which is VS Code
Yeah.
it has the ability to remote over SSH, right? And also code spaces if you want to do it in the browser, in the web browser. And I think both of those are pretty nice environments for doing a lot of this kind of stuff. So that's sort of been my go-to. You can get a pretty beefy virtual machine in the cloud, but still have that nice local, environment for editing, right? But the actual compilation and execution happens up in the cloud. And you can get a 100 plus core VM at this point. I mean, they're not cheap, but you can get a 100 plus core VM at this point if you want to. From a cloud provider and certainly from Azure. And so, it's usually, I hesitate to say that's good enough for anybody, but I think that's pretty good. So that's been how I've been doing a lot of development actually. I really like that VS Code remote support.
So, all right, maybe for our last question is like, what kind of like you see. I guess you did speak a little bit about this with maybe the eBPF thing, but if I could ask you a personal question in terms of like what's in the horizon or maybe the mid to long term in Azure that you're particularly excited about, like that thing that you're saying, oh, I'm really waiting for this to happen, like because it really gets me really
maybe
excited.
I'll say I'm not waiting for it to happen. I'm trying to make it happen. But,
right. Good.
I think we're on a path towards converging platform as a service, Heroku style or function style platform as a service with containers and with container infrastructure, so that really there's no difference and you can move in between easily.
All right. So
so you don't think, oh, I have to do functions as a service and I can't do containers, or I have to do containers and I can't do functions as a service. I think we're on a path to make that programming pattern just a different way of interacting with a Kubernetes cluster. We're not there yet, but I think if you see like the Azure container apps that we launched recently that's built on top of AKS, as well as some of the work that we're doing with in CNCF projects like Dapper, the distributed app runtime, and Kata, the Kubernetes event-driven autoscaling. I think we're pushing from both sides to meet in the middle. And I think someday, just sort of like the railroad was built from one side of the coast to the other in the United States, like we'll meet up in the middle somewhere, and we really will provide that experience where you can start in PaaS and gradually go down to vanilla containers, or you could start in containers and grow up, simplify down to PaaS, or actually do both, right? It's going to take a while, and I mean, if you'd asked me this question 5 years ago, I would have said exactly the same answer, and I would have been sad that in 5 years we hadn't gotten there. So
but we're closer, right? I mean,
I think we're closer.
I think we're closer. I'm an Azure user. I use it like every day, so I see the progress, and I understand why you're going there, because it got confusing when you had like web applications and containers for web applications, or web for containers, and then you had the functions that only run on the Windows runtime, and then it's like it got like complicated, right?
Exactly. It's too complicated, and it makes it too hard for our users, So we really need to simplify that, and we're on the path. We'll get there, but it takes time.
Yeah, and as a customer, I can say you really are. I see the progress there. So thank you so much.
Cool.
I'm sad to say that we are at time, because I could stay here like all day talking to you.
Nice.
But again, like I just want to end by thanking you for kickstarting the project, doing what you do. We are all users here. We all love your stuff, and thank you, for still adding value to our daily lives.
We try our best. So thank you, and I really appreciate the trust that usage comes with. So thank you.
All right, thank you so much.
It was great to be here.
And thank you so much for sharing your time with us.
Absolutely. Take care. Bye.